Hey folks, welcome to Advent of Code in F Sharp. Day 17. It's been a week. Yesterday we left off a bit too soon for my tastes, but we left off when I had to go to work. And we were parsing packets. We were like literally this close to solving part 1. But yeah, as you can see, I got my first star. It's now 3 days in a row where I got the first star, but did not find the time to look at part 2. So I think this weekend I'm going to do a bit of relaxed catching up for those second stars. I took a look at the part 2 for every of these days, and they all look doable in their own right. So I don't think I'll have much problems. I just need some time. Today is the last day I have to get up early for work, so I hope the next puzzles we can finish in one sitting, and otherwise we won't, not a problem. Am I going to go over what I did for yesterday's puzzle? We have a couple of minutes to go, maybe quickly. We'll do a dedicated stream on catching up, or a dedicated stream on day 16, part 2. I also increased the font size, by the way. If you cannot read the text, please drop me a message on YouTube or in chat, and I'll try to make it better for everyone. But day 16, we were actually almost done when we left off yesterday. We were parsing those second kinds of packets, the one with nested packets, the hierarchic things. What did I call them? Operator packets, yeah. And I was doing this mutual recursive function thing where the operator packet parsing needs to parse sub packets, and that's like calling the main parser method. So we had to do some mutually recursive stuff, and that's the AND keyword you see here. Something you don't see a whole lot in F# code otherwise. And there were two modes. I think we might have left off just before I started parsing the two modes, but in essence, they were pretty easy. If you know the total length in bits of all the sub packets, you can just take a look at those bits and recursively parse packets until the string is empty. That's what we do here. And in the second part, you know the number of packets, but you don't know how many bits they will consume. I just parse a packet one at a time until we have no more packets to parse, and then we just continue. Is this remainder thing we've seen yesterday? Something you see always when you write parsers. You eat up part of a string or nibble up part of a string, and you return the rest, so you can recursively continue doing stuff. So that's what you're seeing here. There was a final detail about the inputs being in hexadecimal, not in binary. So I just did a quick hex digit to binary string mapping. It's not too hard. And then the actual part 1 thing was summing up or adding up all the versions of the packets you parsed. And if you have an abstract syntax tree, or if you have like a recursive data structure like we have here, it's pretty easy to do with a reduce or a fold or something like that. So that's where we're at. I quickly read part 2 as well for yesterday. It's just evaluating the packets. Like, those operators now have meanings for part 2. It's not too big of a change. I was contemplating of doing that before stream, or before 17 today. But let's not. Let's just take a look at day 17 first. This does not look like a huge challenge. Maybe we will do it at the end of today's stream, if day 17 at least won't break my brain for 2 hours. So let's take a look at day 17. Do I have day 17 stuff set up? I do. Okay, let's go. Trick shot. So we finally decode the elf's message. Hi. The message says, you continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Mariana's Trench? I don't know. Could the keys have fallen into it? You'd better send a probe to investigate. The probe launcher on your submarine can fire the probe with any integer velocity in the X and Y directions. This reminds me of that computer game with the cannons. I hope we don't have to calculate trajectories. For example, the initial XY velocity would fire the probe straight up. Yeah. An initial velocity like 10 minus 1 would fire the probe forward and slightly downward. This is literally... okay, cool. The probe's position starts at origin, then it will follow some trajectory by moving in steps. On each step, these changes occur in the following order. Okay, those are some rules. Due to drag... oh, it's really that cannon game. If chat knows the name of the game, I'm feeling nostalgic, but I totally forgot what it was called. There's like mountains and a cannon on the left, cannon on the right, and you can even play 2 players, and you have to try to shoot each other, and you have to take like wind and drag into account. Some kind of Windows game. Like the card games, they come built in. But anyway, so we are shooting probes, and we have initial velocities, cool. X and Y positions just increase by their vector components, yeah, due to drag. X velocity decreases, and due to gravity, Y velocity decreases as well. X velocity has a max or minimum of 0. Gravity works. It continues on decreasing. Does that make sense? Yeah, that makes sense. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within a target area after any step. Submarine computer has already calculated this target area, which is our puzzle input. Interesting. So we get like a... we get like an area, cool. Do we get a starting point? Yeah, origin. This is already a cool problem. I know nothing about trajectories, so let's brute force it to get started. Okay, cool. So we need to find initial values for the velocity vector, such that after any step, the probe's x position is at least 20. After each step, I don't understand that part. No, don't understand that part. We'll need to see some examples. I understand the parsing of the target area, sure, given this target area. One initial velocity that causes the probe to be within the target area after any step is 7, 2. This is 7 to the right, 2 upward, yeah. And then 6 to the right, 1 upward. 5 to the right, nothing upward. 4 to the right, 1 down. 3, 2, 2, 3. Yeah, okay, I understand what's happening, but I don't understand that after every step... after any step. What do these T's mean? S is the initial position, the X coordinate increases, yeah. In the bottom right, positions that are within the target area are shown as T. Why do they say, like, after any step, the probe's X position is at least 20, if that's not even the case? I don't understand this problem. After each step, until the target area is reached, the position of the probe is marked with... yeah. I get what they're saying, I just don't understand that after any step part. No, don't get that, but okay. So another initial velocity that causes the probe to be within the target area after any step is 6, 3. So X velocity decreases until 0, and then we just start dropping it faster and faster due to the gravity increase, yeah. Or the acceleration towards the Earth. These are all for the same target areas, yeah. Oh, this is an interesting example. An initial velocity that does not cause the probe to be within the target area. Okay, now I get the after any step. Not after all the steps. There just has to be one step where the probe hits the target area. Okay. Okay. I'm awake now. Probe appears to pass through, yeah, but it just misses it. It flies straight through. We have discrete time, not continuous time. Cool. You might as well do it with style. How high can you make the launch probe go while still reaching the target area? That's a fun part 1. So how high can we shoot our probe while we still reach the target area? Interesting problem. I know nothing about like trajectory stuff. I don't really feel... Should we be doing a smart thing from the start, or can we just brute force? I think we can just brute force and we can like intelligently stop looking. If we know it's like a hopeless... If it's a hopeless case where we are way past our target area, or not way past, if we crossed our target area, like we are to the right and below it, forget it. This probe is lost to us forever, to the bottoms of the sea. I think I'm gonna tackle the problem like that. We just brute force it, shoot... yeah, shoot wherever. And if we cross the outer corner... Is it even the outer corner? We can't go back, right? Yeah, if we're to the right of our target area, or even if we're below the target area, we know gravity and stuff will never get us back to that area, so we can just stop. Let's do it that way. How many examples do we have? We have the single example. Cool. Let's see what our input looks like. That's not even worth parsing. That's just something we might encode into a variable, something like that. So I'm not even gonna parse today. I'm thinking, is there an F sharp or a C sharp? Is there a .NET representation of ranges, like beginning and to end? Code bases I've seen always declare their own custom type, so let's do that. Let's declare a range to get started, to warm up a bit. So it's integers will be enough. Yeah, sure. So we have a range and we have a target area. X is a range and Y is a range. Sure. So our input is actually just a target. No need to parse anything. X equals 14 up until 50. Y equals same, but then minus 267 minus 225. Yield is totally not what I want here. What is it saying? Invalid record sequence computation expression. What? Why is it failing suddenly for Y, not for X? The minus? Probably. Please work with me. It's not the minus? Interesting. Oh, it is the minus. No. It's not X and Y, it's minus max. Okay. I still need to wake up a bit. So actually writing a parser would have been faster in my case. So let's double check that. So we are not solving the incorrect problem. 20 minutes for now. Yeah, that looks okay. No, that's a bug. It's 225. Thank God we double checked that. Yeah, that's correct. Let's also grab the examples so we can play around with the things we actually see in today's... Come on, format for me, thank you. What's the example again? This is the example. $20.30 for X. Minus 10, minus 5 for Y. Minus, minus. Interesting, okay. We have our stuff to play with. Our brute force is going to try every angle, and our goal is to find the trajectory or the vector that still hits target area and has the highest Y coordinate. So we're looking for XY tuples. let me just write that down. Looking for XY where we hit targets. And we need the one with max Y. So let's generate all the vectors, then filter out the ones that hit the target, and then take the one with the highest Y components. Make sense? Makes sense. And we can get rid of the ones that we know fly by or fly straight past our target area. Are the target areas always to the right? Yes. Are they always to... They are always below? Like minus, minus? That minus thing is throwing me off a bit. Why is it minus? All of a sudden? Up until now, every 2D grid thing thread of code this year had like Y growing in the positive direction, and now Y suddenly is negative. How do I interpret this? Is this minus 10? Probably. This minus 5? 1, 2, 3, 4, 5. Yeah. Okay. I'm just trying to get things straight in my head. Okay, let's go. So, what's like the range of XY coordinates we need to take a look at? X will decrease by 1. Yeah, X will decrease by 1 every discrete time unit, and Y will also, but X doesn't go negative. X just stops, and then the probe falls straight down, like in this example. So we need positive X's. Yeah, we need positive X's, and I think we can even stop when we reach the target area, right? That's even way more than we probably need to do. If X is 20 and the first tick doesn't reach a target, then we'll be at 40 for the next tick. But yeah, let's, to be sure, just gonna write a for comprehension that generates all the possible vectors we can take a look at. And let's have that start at 0. 0 is a bad example. 1 is also probably not the winner here, but okay. Yep. I'm gonna write an alias for target, so we can swap in example and input later. So we now have a target, and let's try to... am I still making sense in my head? Yeah, so let's try to generate all vectors from 1 until the target dot x dot min. I don't think it really matters that much. I think those are good x coordinates. Probably y. What can our initial y coordinates be? Do the probes always go up? Does it make sense to explore the negative y search space? We are looking for the highest y coordinate. I'm just gonna try starting off with, let's make an assumption here. And I'm gonna explicitly write it down, because if it turns out not to be true, then this is the first thing we can investigate. Only positive y's are interesting. So if you take positive y's, it's probably same principle. No, we can't go up until like some max value here. Let's see. We have like x ranging. X doesn't go very far. It's like 50, 30. Y's are somewhere in the lower right of where we are. Y's are like the height of our probe or vector. The y component. I don't know actually. What's a good thing here? Integer dot max value. 100. I have no idea. I'm gonna hardcode a 100. No, I'm gonna hardcode a... Yeah. I have no idea what the smart thing is, so I'm not even gonna bother. I'm just gonna play around with it until I see things in action. I need a arrow or a do somewhere. I need a do somewhere. Okay. So, yeah, we just generate stuff. A lot of stuff. And we try to run or shoot our probe or simulate a probe shot, at least for all these core vectors. Let's call them vectors. I'm gonna put that assumption a bit more to the left. Yeah, that works. Cool. So far, we have done nothing for today's puzzle. We've just been generating XY coordinates. Not a problem. We're just getting familiar with the problem domain. So how do we simulate all those probe shots? I guess by simulating them one after a time. So let's try to simulate one. So that V is the first vector. How do we simulate it? We just keep going, keep looping, keep applying those XY rules we have. Step, yeah, let's call them step. So let's write a function step that applies these rules, and we can stop once we are past the target. So I'm gonna quickly copy paste those rules in here so we have an overview. That's a long sentence, especially with a huge font size. There we go. No, so we're writing a step function. That step vector equals, it will be a new vector. Yes, it will be a new vector. So I'm not going to call it vector, I'm going to call it XY directly. No, it makes more sense to read the signature like this and then say we do the destructuring here. I saw that C# already is a way advanced in destructuring, or at least the latest versions. That's pretty cool. That's one of the features I miss when I program in C#, and now we have it. Cool. Now we just need some discriminated unions, and I never have to take a look at F# in my life again. Anyway, let's take a step. Oh yeah, we don't actually only need state, we need probe position as well. I'm gonna encode that. So it's probe state, and we have a position. Do I have... These are just ranges. Yeah, that's not the same concept. That's not the same concept. So we have a position and velocity. I don't know why I'm writing off. Off is not really relevant here. There we go. So we have state, velocity, velocito. Don't know what that means. There we go. So we are working on state, not on vectors. State, not vector. Come on. I'm almost awake, I promise. Yeah, let's just apply these rules. Let's go big or go home. I'm using this tuple or record syntax, update syntax thing. We don't really need it because we are changing all the things, but it's clear to me this way. It's like we're generating a new position based on the initial state, or we're generating a new state based on the given state. So no, it makes no sense what I'm saying. Let's get rid of this state width thing. So that's a tuple. And velocity is also a tuple. Let's just first make sure compiler likes what we're doing. Cool. And let's take a look. Probe's X position increases by its velocity. So it's the velocity. It's a capital thing. And it's not X, it's a tuple. You know what? I'm going to make a... I'm not going to work with tuples today. Location is a record. Is it a record? Will this hurt us? Nah, it's okay. It has an X and a Y. And let's use that location instead of these tuples. Tuples are nice because you can do like... You have collection functions like zip and unzip, but they're not very explanatory. Velocity. Location is not really a good name for velocity. Actually, it's two different things. One is a coordinate, the other is like a vector. I'm just going to call it vector. Position vector. We're not being really correct here, I guess, but I do not care. So probe's position increases by its x velocity. Probe's position increases by its y velocity. Is y... Yeah, y probably starts off positive, but that flips sign somewhere midway. Yeah, this is now not a tuple. I was getting confused again, but I think if we do this, and we change the correct y, and we use correct y velocity, I think we will compile again. At least for the position part. The velocity part, probably much the same, but easier. So probes x position, probes x velocity changes by 1 towards 0, but never less than 0. So its velocity just decreases if it's larger than 0. Otherwise, we stay at 0, but for y, we don't have such constraints. No. So state dot velocity dot y minus the 1, and here is the x. Is what I'm reading here. Does that make sense? So increase x, increase y, velocity decreases by 1 unless we are at 0, and y always decreases by 1. I think that is okay. Let's try that out. Yeah, let's try that out. So we need an initial state. Position starts off at 0, 0. I'm already regretting my record instead of tuple decision. It's a lot of typing. There we go. Velocity equals the initial velocity. That's now also a tuple. Oh, why did I do this? Not a problem. Not a problem. I'm not here to win any speed records today, or any day for that matter. Let's put those types here. Let's, when we generate the pairs, let's make it a XY thing. It's the fun part about languages that have REPLs or interactive windows. You can just evolve your code, play around with it, and as soon as you have something stable enough, you can make that experiment more permanent in a unit test or whatever. It's really, I find it a really refreshing way to program. Okay, that's better. So we have an initial state. Let's try taking a step. So as a manual verification of what we have been writing here, x increases, y increases, and these decrease. Yep, let's take another step just to be sure. Yeah, both don't increase because they're 0, that's right. X is 0, so that does not increase any further. Y decreases to a negative thing, so one more step, we should see x1, y0, right? Yes, x1, y0, and the gravity is pulling us towards the Earth faster. So we have some acceleration going on there. Yeah, I think we're almost there. I'm gonna wrap that build initial state thing into a function. Or at least I was hoping to put this in a function. What is going on? Okay, there we go. So we can build an initial state for every vector. We have a take step. Now we just need a halting condition, or we need to know when we give up on a vector. What will that look like? So say we have a vector, say we have initial state. We have initial state, there we go. We take steps, we take steps, we take steps. If we hit the target, it's a valid candidate, so we return it. If we fly past the target, it's not a valid candidate. This sounds like a job for the option type. Let's go with the option, or with an option. So what I want to do is, yeah, I want to iterate over this take step function, or I want to call it, keep calling it until we either reach target or either fly by it. So I'm too or I'm not awake enough to think of anything smart, so I'm just going to write a recursive function that does this, and it returns an option. So the thing I'm trying to build is evaluate a vector. So we have an initial state, and we take a step. So let's evaluate state instead of, no, let's evaluate a vector. We'll do the recursive thing one level lower. So we take a step of that state. Or we first do even the boundary check. And then we take a step. Yeah, so let's try that. Eval state equals, and then we do this and do a boundary condition. And if we call that eval function with state, I'm using like 4-letter, 5-letter function names. I will hate myself an hour from now when I don't understand what's happening anymore. I guess, but that's not a problem. We'll deal with it when we get there. We can rename stuff. That's an easy, cheap refactoring. So evaluate takes a vector. We call something else with a state, and this thing we can do like a stop condition. Yeah. We also need the target, right? Yeah. I'm not gonna pass it into the inner function because target never changes. We have a fixed target to hit. And because we nest these two functions, that inner function eval also has access to target. So you can do like target dot x dot, was it x? No, min. And that's a range, right? That's a range. Yeah, sorry, I'm drifting off here. But what we're doing here is checking or not whether we fly past the target, not the range. I see like a bit inconsistency here. Let's name all our things with capital stuff. I see red squiggly lines, which means I'm breaking things. I did not expect this. Input is a target. Thank you very much. Yeah, if you have records and you don't specify your types explicitly, if you have like 2 records with the same properties or the same fields, you're in for some trouble. That's what we're seeing right now, but everything is compiling again. Cool. Let me make those types explicit. This is a target and vector is a vector. What is a vector again? Oh, we have a type called vector. Cool. Thanks, past me. So if target dot, no, if state dot, it should kind of know this is state. It will know it once we start having code that compiles again, but right now we don't really. So if state.position.x, if we're past our max range, we can give up. Or faster target. So giving up is returning a none. If we have found still a valid candidate, we... Oh yeah, we don't only need to return none, we also need to return the something. That sounds even more interesting. Let's do that first. Let me just make sure we compile again. Let's return something. No? I'm trying to have it compile, and then we can take a look at the happy path first. So I think this is all we need to do, but this needs some more attention on our side. Let's first do the happy case, where we magically end up in the target area. That's enough to put into its own function, right? If the position falls in range, then we have a nice candidate to return. Do we need to know the position? We are evaluating a vector against the target. It makes sense to just return the vector, the initial vector, yeah. Falls in was something we did not write yet, so let's do that. That's just a boundary check, so it's a target position. What's the red squiggly here? It's missing an if branch. Yeah, it's true. I don't... Let's use the full phrasing else if. Seeing elif in code, it's like I'm back in some a more mature language. Language with more years under its belt. Anyway, falls in. Let's finish part 1. Because it's already 30 minutes in. So if... let's maybe specify the types. What's the position again? Come on, give me syntax, give me highlighting, vector. So, position should be in the target dot x range, right? I'm just gonna hammer it out right here. It's not or, it's and, right? Oh, we could do both ways. If the position dot x is smaller or larger than the max, or same with y. Will this work? I'm terrible at stuff like this. So we have y. Yeah, if we fall out the maximum value of something. Wait, what do we need to do now? It's outside, right? Yeah, this is outside, so let's do a not of the whole thing. Very cryptic, not my favorite, not my proudest moment. Should we give this a try? We should. What's the example again? 20, 30, minus 10, minus 5. Position is a vector, which is a xy thing. I'm just gonna play around with it to verify it a bit. So that looks correct. If we fall into the 20, 30 range, minus 10, minus 5. Minus. Did we take minus into account? So this should be in range. Cool. Minus 5 should still be in range. Yeah, minus 4 drops out. That is correct. Minus 10 is still in range. Yep. 11 should not be. Cool. What was the X boundary? Let's test that boundary again. So 22, still in range. Yep. 30, still in range. Cool. Yeah, I'm convinced this is good enough. So this is in range. So if a position is in range of the target, we have finished and we have approved of this vector. Otherwise, otherwise, if we flew past it, that's what we're doing now. We don't care about this vector. If we do state.position in range, maybe we can do state.position too far, something like that. Flew past. Yeah. It's almost the same thing, I guess. If it flew past, we don't care. Otherwise, we just take another step. Yeah. What does flying past the target mean? So it means that position dot x is larger than the target dot x dot max. That's for x coordinate, yeah, and then for y coordinate, at least for the examples and the input we have, if we are min max, it's a bit confusing, no? am I in the right here? Yeah, the whole thing that the y coordinates in today's challenge have flipped. It's confusing me a bit. We're saying max, but it's like the closest to our start point. So yeah, I'm not. I won't be surprised if we do a y bug somewhere. But anyway, we were taking a look at flew past. So if position.x is larger than x max, we flew past it on the x-axis, yeah. But then target dot y dot max. We need to do something with this. Or min. Min? Yeah, if it's above max, it's not a problem. We have to fall into it. So we need to do something with y minus. And let's say y is minus 9. That's okay. This whole negative thing is messing with my brain. Let's write out some examples to figure it out. So y in range. Minus 5. Yeah, no, flew past. That's what we're doing. Minus 5. No, we're still good. Let's do a multi-line comment so I don't have to repeat myself. Minus 6. No. Minus 9. No. Minus 10 is still okay, but barely. Minus 11, that's when things go wrong. And a minus 5, minus 4 are also okay. So yeah, definitely need to take a look at the 10, not at the 5. So we definitely need to take a look at min. What do we need to do? It has to be smaller. It has to be smaller. Than the minus. Minus 11 is smaller than minus 10? I think so. I don't know why, but this is proving to be PhD level mathematics for me today. Cool. Let's give it a couple of experiments. Example is the thing with the minus 10. Yes, it is. So if we hit 30, that's still okay. Cool. If we hit 31, we will never get to the target again. Yeah, cool. For the y, positive numbers should be okay. Cool. 0 should be okay. And just like from the top of my head, thinking about cases, let's take a look at a couple of those cases we based our algorithm on. or simple boundary check at least. 10 should be okay. 11 should be a problem. It is. Do I write tests for this? Hell no. Let's keep going. So if we flew past the target, we don't care about this vector anymore. If we have no winner or no absolute definite loser, we just continue. I think we are done for a single vector. So let's try that. Do we have a V? We do have a V. We don't have a V? Ah, we don't have evaluate yet in the REPL. Cool, that works, or at least that compiles and returns a none. I think we can now just filter the vectors. Yeah, we can just filter the vectors. So, vectors. Is it a list? It is a list. Let's choose the winners. Evaluate takes a target, so we need to provide a target. And the vector is the thing we are piping in. I'm gonna call it evaluate hits target. So yeah, we grab all the vectors that return a sum value, and that's something you can do with a list.choose. We have a list of vectors and it's beautiful. So these are all the vectors that eventually end up right smack bang in the middle of a target. I guess, I hope. So we just need to grab the one with the highest y coordinate. So that's vector.y. And it should be max by, not max b. That looks like an artist name, singer name or something. 6-9, is that correct? Hey, that looks correct. Oh, we need the maximum y position as well. Find the initial velocity that causes the probe to reach the highest y and still eventually be within the target area. What is the highest y position it reaches? So yeah, we know the vector, we don't know the highest y. That sounds like something state should keep track of. Yeah. Let's keep a highest point in there. And in our init function, let's initialize the highest point to the current y, which is 0. And everything still compiles, but where we take a step, we need to update highest point as well. Yeah, that makes sense. Everything compiles. So we just need to take a look at the new y. This is the new y. I'm gonna extract it into a variable. We could keep track of all the y's as well. I just want new one. I just want the highest one. So it's a state dot highest point or new y, and we want the max. Probably not the most efficient way, but it's cool. So now state knows about the highest point, and instead of returning just the vector, let's return the highest point as well. Let's wrap both these things into a what is the highest y position? So we need to do some more work here. This is a vector and the highest point. So we sort on largest y and just grab the highest point. which is the second component of this tuple. So that should be, what was it, 45 again? It is 45. That looks pretty sweet. Now I hope that the actual input also runs as smoothly. So let's grab everything. This is that code. I was playing around with stuff. This is relevant. This is just our input in the example. Type definitions. Yeah, that's all we need. Let's drop that here so it's a bit closer. Yeah. So input now instead of the example, and we do the same thing. And we get a nice little number. Oh no. That's not the right answer. This is going to be fun to troubleshoot. Let's verify our input first. When in doubt, always verify input. So target area 1450 minus 267 minus 225. Too bad, that's correct. Yeah, that's correct. Interesting. Is there a difference? Is there like a structural or a major difference? I don't see it. Are we using examples somewhere where we shouldn't? No, it's dead code. Super dead code. I'm gonna clear my REPL just to be sure we're not chasing ghosts here. I think this is the first time this year that I'm hitting a wrong solution without like a clear indicator of uh-oh. Maybe our assumption, I have like one big assumption somewhere in the code. 3828 is not correct, so let's write that down somewhere. 3828. Could this be a problem? Of course not. Maybe? Maybe. This was the ugly assumption, or the assumption I'm not sure about. If we use a larger X component, what's the current X component here? 14. And what's the maximum? 50. Does it make sense to stop at 14? Probably it does not. Let's increase both our spaces a bit, our search spaces. That stays the same, so that was not it. I'm just gonna brute force my way out. I'm not going to think too much. This is breaking code. Okay, this is interesting. This gives us a totally different value. Why did I assume like 100? Maybe because I saw the example and made an assumption I did not explicitly like pause by. Yeah, apparently. Still don't like the hard-coded 1000 here, or what was it? But it's Advent of code. We're not here to build general purpose production ready code. We're here to have fun. So, which is exactly what we're doing here. We have the correct answer. Let's just keep track of that. Maybe for part 2 that might be relevant, maybe not. But let's take a look at part 2. Doing my old copy paste the file so we can forget about part 1 and hack away. What will part 2 bring? There's that white thing. Let's get rid of this. Cool. Part 2. Maybe a fancy trick shot is not the best idea. After all, you only have one probe, so your head better not miss. To get the best idea of what your options are for launching the probe, you need to find every initial velocity that causes the probe to eventually be within... Wait, we need to find every initial velocity. Every initial velocity. Phew. Is this not the same? Yeah, but instead of finding highest y, we just need to count the different... We just need to count the different initial velocities. So we still have a set of all the velocities that hit the target. Did we overkill part 1? We probably overkilled part 1. If I look at this, this is basically what we did. Cool. Let's do it. Find every initial velocity, and velocity was a xy vector. Yeah. And we need to find the different ones. We can have duplicates. That's not too bad. Do we not already have everything in place for this? Let's grab the example again. Let's grab the example again. The REPL has some trouble waking up. All I did was run some code. Come on. There we go. So instead of maxing by and taking the highest position, let's get rid of that highest point thing. No, let's keep it in. That won't be a performance issue. So these are all the vectors. Let's put them in a set. So we have only the different ones, or we can do a list of distinct. It's the same thing. These are the number of different initial velocity values. This was not the hardest of part 2s. He said without actually taking a look. 19, is that correct? Totally not. We probably are excluding part of the search space, right? What do we see here? 23, 25, 8, 29, 30, 24. What is the example again? 20 to 30, minus 10 to minus 5. 20 to 30. So if we grow x from 0 to 30, that should cover all these cases. There is even 30s in there. There are 30s in there. That's interesting. This is generating... yeah. This contains 30s, right? Let's generate that list for x only to verify, but I think this contains 30s. Yeah, that contains 30s. So that part of the search space we are covering. Are we not covering everything in the Y space? Of course not. We are starting from 1 and we're only growing it. We're excluding what, half of the search space? It's pretty interesting that part 1 worked. How could part 1 have worked? What does a negative gravity mean? I'm shooting down? Probably. So it's not starting from 1. It needs the 1000 for part 1, so we need to make a smaller initial. Yeah, we need to make a smaller initial y. That'll work. And we grow our y's in that generator function. So if we start at this thing, we start at the -5 thing, I think we're good. -5 is y.max. And we increase that by 1. Yeah. like 70% sure that now we'll get a better result. Oh no, it's blowing up our CPU. Oh no. Dang it. That's better, but not much better. So we have 19. Yeah, so this is definitely an improvement. 57, we're not even halfway there. Let's print out the... Are these like sorted in any way? These look pretty random to me. How will we verify what we're missing? $112 is a lot to is a lot to compare by eye. Okay, I'm not proud of this moment. Forgive me. I just want to make sure that the algorithm is correct. So I'm just gonna start growing our search space very naively, which works. Probably it's if we only like do a minor tweak. There is maths behind this. We don't need to randomly guess. I just am not feeling up to really thinking about it. Yeah, so this works for a definition of works. This is burning up our CPU, so maybe we do need to do the math. That number looks awfully similar to... Oh no, it does not. I'm sorry. Let's see if this works. That worked first try. I'm almost sad because now I don't think about the problem. we brute forced our search space bit. But I have like 3 days of part 2 catching up to do. I'm not gonna stick with it. Oh, good morning, chat. I totally lost track of you. So yeah, this is part 2. I'm super happy that we got 2 stars. There is maths. You are very welcome to figure out the maths. This is the only part of today's puzzle I am really not proud about. These boundary conditions on like generating interesting candidates. Nope. But other than that, I think I'm pretty happy with today. We did complete overkill on the types. Yeah, we did some overkill. I don't know if were I to solve this puzzle again, I might have just dropped into the 2D or the tuple space, not with custom types. This is a bit more explanatory, but for these 50 lines of code, that was not really necessary. Fun puzzle. Still don't know the name of that computer game though. Let's do a quick search. Pretty old games. That is an apt description of what I'm looking for. Yeah, this is exactly what I was thinking about. So, bang bang. We did some bang bang vector calculations today. I had fun. I hope you had fun as well. Not gonna do part 2 of the other days today. I'm just gonna take a short Advent of Code break, and I think I will do some catching up this weekend. Thanks for watching. Have a nice weekend. Have a nice day or evening. And I'll see you next time on Advent of Code in F#. Bye bye.